Hello and welcome to my Math Companion. In this video, I'll explore simultaneous equations using the same problem that we did in the previous video. However, this time we'll be using the subtracting equations method. In the previous video, I had used the method of substitution of a variable, and today we'll be using a different method. So, in this problem, Jack and Bill are playing cards. Jack knows that 2 times his number of cards is equal to 2 less than 6 times Bill's number of cards. Given that Jack has more cards than Bill and the difference in their number of cards is 43, how many cards do each of them have? So now our first equation will be 2j equal to 6b minus 2, since 2 times something is 2 multiplied by that something, and 2 less than 6 times Bill's number of cards is 6b minus 2, and the question states that these two are equal. Our second equation will be j minus b is 43, since it states that the difference between the number of cards is 43 and Jack has more cards than Bill, and hence if this number is positive, j minus b must also be positive, and therefore j must be greater than b. Now, in order to solve a simultaneous equation by subtracting equations, you need to eliminate one variable when subtracting one equation from the other. And here we see that we have 2j is equal to 6b minus 2 and j minus b equal to 43. And if we were to multiply the entirety of equation 2 by 2, we would get 2j and 2j in both the equations, and thus we could easily subtract one from the other. However, when you're subtracting two equations, you can only subtract the left hand side from the left hand side and the right hand side from the right hand side. So what we will do is we will move this negative b to the right hand side first to ensure that on the left hand side we only have j's. In order to do that, we'll add b on both sides and we get j equal to 43 plus b. And now we multiply the entire equation by 2, which means we multiply the left and right hand sides by 2. So that gives us 2j equal to 86, which is 43 times 2 plus 2b. So now we are ready to subtract. We will subtract equation 2 from equation 1. So equation 1 is 2j equal to 6b minus 2 minus of the entirety of equation 2. This means that this minus is being applied to each of the terms. It's just like how you have binomial expansions. Each term gets multiplied with each other, and therefore this minus gets applied to each and every single term. So you would get 2j minus 2j, which is 0, which was our desired result on the left hand side. Then you get 6b minus 2b, which is 4b, and negative 2 minus 86, which is negative 88. So now we have 0 is equal to 4b minus 88, and if we are to solve for b, we must move this constant term to the left hand side, and to do that we must add 88 on both sides, and we will get 88 equal to 4b. To isolate b, we will divide by 4 and get 22 is equal to b. So notice that this was the same value as obtained previously in the previous method of substitution, and it will be the same value since the question is not changing. Next, we must find the value of j. So we know from equation 2 that j minus b equal to 43. So when you select a certain equation to find the value of the other variable, you must be smart in selecting it, since you want to do minimum number of operations, minimum number of calculations in order to find the value of this variable. And since the coefficient of j here is just 1 and the coefficient of b is negative 1, you can easily calculate the value of j without much difficulty. Coming back to a problem, we can now add b on both sides since we want to isolate j, and we will get j is equal to 43 plus b. Inputting this value of 22 for b, we see that j is equal to 43 plus 22, which is 65, which is the same value again as obtained in our previous video. So this means that Jack has 65 cards and Bill has 22 cards.